So as you know, I have made a number of observations in recent weeks of the Earth's shadow crossing the line of geostationary satellites, and this is only possible a few weeks either side of the equinox. In fact, in about 48 hours, the shadow will move away from that line of satellites, and we won't see them eclipsing again until we approach the March equinox next year. So last night I set up the telescope again at Broome Airport for another observation. Specifically, I wanted to see that the period of the eclipse was shorter than what we had on the day of the equinox. But as I was waiting for this to occur, I noticed something else worth capturing. Here we have Himawari 9, Himawari 8, and the three following satellites. But I noticed another satellite up here. That is actually Beidou 3. What was significant about that satellite is that it actually went into the eclipse after these 5 satellites, and this is due to the geometry of the Earth's shadow at this time. If we just run the simulation in fast forward time, you will see these 5 satellites disappear before this one does. Now, when I realized that was going to occur, I had to adjust the position of the telescope slightly. I moved this line of satellites down in the frame, and you will actually see that occurring in the time lapse. So I moved it down manually, and that allowed Beidou 3 to come into view up here. As the satellites entered the eclipse, we see the 5 in the lower part of the frame disappear first, exactly as the app predicts. There they go. So all 5 of them gone, and yet Beidou 3 is still visible. A short time later, it also disappeared, and it was the first to reappear. So there we can see it is just reappearing before Himawari 9 or 8 reappears. So let's take a look at why it occurred this way. So I'm going to run a demonstration now that will help us better visualize why these 5 satellites disappeared into the shadow before Beidou 3. In Sky Safari Pro 6, we can identify the position of the Earth's shadow, and these 2 white circles represent the center point of that shadow on the 11th of October, last night when I made this observation. This white cardboard circle is a better approximation of the size of the Earth's shadow at this scale. And when we run the animation in fast forward time, you can see very easily why those 5 satellites disappeared first. Just like we see in the actual observation. So I have the telescope tracking now turned off, and the satellites Himawari 8 and 9 are in the field of view. What I just did was a very slight manual adjustment. They were previously at the center of the frame. That's Himawari 8 and 9. But what I did was move them just to the lower portion of the frame, because we have another satellite up here, Beidou 3. Now, with the geometry of the sun and the Earth's shadow being round, these 5 satellites, Himawari 8 and 9, plus the following 3, should blink out before Beidou 3, because that is actually moving through a much smaller portion of the Earth's shadow. So when I run the time lapse, you'll see that the position of those 5 satellites moved from center frame to the lower portion of the frame, allowing this one to be in the field of view also. We have about 20 minutes to go before Himawari 9 and 8 start to blink out. So as we saw in a previous video, the maximum period of the eclipse occurs on the day of the equinox, and it has been reducing ever since. If we take any of these satellites and note the timestamp when they disappear and then reappear, we can see that they are eclipsed for less than 40 minutes. Looking at Sky Safari Pro 6, the declination angle of the sun last night was -7 degrees 20 minutes. And if we put that value into the eclipse period calculator, 7.33 degrees declination, we have an eclipse period of 37 minutes and 47 seconds. So once again, the real observation matches the prediction based on the globe nicely. So it's Monday today, and I plan to make a further observation tomorrow night. With the sun's declination angle steadily increasing, the Earth's shadow is moving away from this line of satellites. Tomorrow night, we should still see these 5 satellites entering the shadow, but this one here, Beidou 3, will be visible the entire time. And the following night, on Wednesday, none of these satellites will go into shadow. I plan to try to make that observation also, weather permitting. Broome Airport is a fabulous location to set up the telescope. So I've just got the telescope set up on Jupiter now, and oh, this is the safety officer. Hey, good, thanks. Have a good one. How good is the airport night safety officer? He drove away and came back with this chair for me. A big shout out to Broome Airport Management and their team. Love your work.